My name is Saurabh Jain. I lead our product development for smart cities at NVIDIA. And today, I just want to talk about what we are doing in the world of video analytics. Kind of share our ideas, our vision, and then hopefully start a positive dialogue with all of you in terms of how you see applicability of some of these technologies to solve some of your customers' problems. And that is an important, hopefully that dialogue will help us bridge some of these new concepts, new ideas, and map them into the everyday problems and challenges that you see, and in the process teach us also on how we should improve or do things differently to better suit the needs of this industry. To get things kicked off and sort of level set, for those of us who don't know who NVIDIA is, we are a company with a genesis in gaming. We were established in 1993, around which time we developed or we invented the modern graphics processor. And since then, we've been continuously marching along in terms of enabling newer and newer areas with the power of this GPU or graphics processing units. Today, practically most of AR and VR deployments, for example, are powered by NVIDIA GPUs. Whether you're training doctors or soldiers, VR and AR is massive now. AI in hyperscale computing, so big data centers, whether it's your search algorithms, whether it's your mapping algorithms, whether it is your face tagging algorithms on social networking sites, or whether it is voice search. This is all powered by AI and deep learning with NVIDIA technologies in hyperscale data centers. And we are now pioneering the self-driving revolution, practically working with every known automaker out there to help design them their future cars. So what we're saying is, GPUs are becoming sort of this cornerstone of the next generation of products and technologies. And it's interesting. It's been an interesting ride for a lot of us who have been a long time in the industry with NVIDIA to see this revolution in the making. Since inventing the modern GPU, we have been on the forefronts of pushing the computational capabilities. Our early work was driven by gaming, and gaming happens to be one of the most computationally expensive workloads out there. And many of you may know Moore's law now essentially governed the silicon industry in its early days, and somewhat still governs the sequential world of CPUs. But we've started to push the limits of Moore's law with GPUs now. In fact, we're way past its predictions and its promise. What you would find is what we're really doing with GPUs is bringing an order of magnitude computational horsepower year over year, which was unfathomable and unforeseen in the past. We're talking on an average of 1.5x to 2x year over year improvements in what computational horsepower you can put in your workstations, your PCs, your laptops, and your data centers. And then in 2012, the big bang of AI happened, really, and especially as applied to solving some of the most difficult video problems. That year, researchers from University of Toronto, for the first time, used a deep learning network to classify 1.2 million images and put them into 1,000 different categories. And that really, really transformed how video analytics, video analysis, video understanding was to be done in the future. Two fundamental things made that possible. First was lots of data. There was suddenly a lot of data to bring these AI and deep learning networks and deploy them into real world. And number two, computational horsepower. The theory of AI and deep learning is not new. It has been there from this late 70s, early 80s. People have been talking about AI and artificial intelligence for a long, long time. But really, there were no means until recently to bring these outside of test labs and deploy them into commercially viable systems. Today, deep learning and AI is transforming practically every facet of our modern lives. Most recently, a deep learning solution from Google called AlphaGo beat one of the grandmasters in the game of Go. Game of Go is a board game, one of the most complex games out there, with many possible moves. It is helping with state-of-the-art facial recognition. Deep learning and AI systems are learning to create original works of arts by learning from the styles of master artists. Deep learning and AI is constantly being used for speech analysis, natural language processing, speech synthesis, writing captions for videos, to healthcare, understanding diseases, understanding acquired images from our CT scanners and ultrasound machines, all the way into self-driving cars. It's practically everywhere. It's almost becoming like, at NVIDIA we talk about this a lot. We almost think of this as the new electricity. It's going to be everywhere, big or small, from your Nest thermostats all the way into enabling Google Now and Siri. It is going to be practically everywhere. And so to continuing to enable and to accelerate this revolution, we created a suite of platforms that span from all the way to the smallest on the right, called Jetson, which is really a credit card-sized supercomputer, all the way into data centers, running thousands and thousands of these GPUs for a variety of different speech and video workloads. We have talked about AI, we have talked about deep learning, and we see that every known industry demand is getting impacted by it. But fundamentally, just want to touch upon what exactly we mean by deep learning. What exactly is this thing? How do we build it, and how do we deploy this in real world problems? At the crux of all deep learning systems is a neural network. Or because these are artificial systems, we call them artificial neural networks or deep learning neural networks. And think of this as really a model of, or a way to mimic how human brains work. These networks are truly represented as bits of code in big computers. But their structure, their architecture is like very similar to how our brains are wired. And so building these systems is very much like training our own human brains. Which is like, so in this particular example, if I'm trying to train or build a system to understand my images or my video, the process is very identical to like teaching a kid, where you show him lots of images of cats and dogs and buses and airplanes, and over time he adapts, he learns that what animals and what planes and what ships and what cars look like. Something very similar happens for training and building these deep neural networks. You show them lots and lots of images, and more images you show it to the networks, the better it gets over time. Once you have these trained networks, which are now capable of understanding the images and the content that you have trained it with, you really take it and deploy it as part of your overall system, where now you feed it unknown data, unknown images, unknown information, and it puts it into the right bucket. It classifies it as a cat, as a dog, as a gun, as a bus. The beauty about these little brains is they're very much like our own brains. They deal with the unknowns and uncertainty generally very well. So, for example, these networks, even though they may not have seen, a certain breed of dog in their original training data set, but they ran into it in real life situations, chances are that it may still be able to classify it as a dog, just like we humans can. Questions?
Yeah, just a quick question. So during that training process, is it human interaction that's saying the yes cat or no dog, or are you using other software to feed these images and then auto?
Today is mostly human interaction.
Okay.
So we call it a process of annotation. So you're basically annotating your images or your data with labels and feeding into the network. Say, these are all images of dogs. These are all images of cats.
Does deep learning learn mistakes and then correct its own mistakes?
The answer is yes. That is the promise. And that is what a lot of modern systems are attempting to do. And the fundamental principle is the same. When you make an error in the last stage, there is a feedback loop that goes into all the way, takes you back into the second stage of training, where you say, oh, you classified it as a dog, but it was not a dog. So next time, the network is trained to classify it or not classify it appropriately. So there's this constant feedback loop that can be established between the output and the training side to have networks continuously learn.
Yeah, but the feedback that you're talking about needs to have human intervention for the training.
Yes,
So
absolutely.
It's a human eye looking at it saying, okay, you classified wrong, here's a fix.
Absolutely.
Go try it again.
Absolutely. And again, I mean, this is the state of art today. Where we see this going is networks are starting to train or help train networks by providing annotated data. So you have, 5 years ago there was this blank canvas. There was nothing. So there was a lot of human intervention, and you created these first order networks. Now these first order networks are becoming smarter enough to give you more annotated data to create your second order networks. And so this incremental training, as we call it in technical jargon, is starting to become more and more real. And this is being facilitated by this massive amounts of computational horsepower and tons of data that is out there to make these networks smarter and smarter. And the fundamental benefit of these networks, or this setup, is the fact that, because of the fact that it mimics the human brain, it brings a massive amount, or it offers a massive amount of scalability to deal with unknown situations, to deal with fuzziness, to deal with uncertainty. And that is why we started looking at this to solve some of the most difficult problems we see around every day in our cities, in our lives, in this industry. Broadly speaking, bringing efficiency and delivering safety. Today as a company, we are very much focused on using video and video as a sensor, because we believe that it's one of the richest sensors out there, and has lots of tangible information that required in the past literally a human to watch it and harness the metadata, the information, the content that was encapsulated in it. We used to literally sit across monitors and watch video frames to understand, the traffic flow or people jumping over fences. But as more and more cameras get deployed, if you read one of the IHS reports, they're claiming about roughly 1 billion cameras by 2020 out there in the world. Watching these cameras and doing and processing these manually becomes an impossible undertaking. There's no way we will be able to watch these cameras and process these, or humans can watch these cameras and process these. Not only that, many of you are probably familiar with video analytics, and it's that was out there roughly 5 to 10 years ago, and the challenges with it. It simply did not work in real life. It worked great in labs, but it was extremely hard to scale when you take it outside the lab and actually deploy it. It required tons of calibration. It had very limiting operating bounds. And in spite of all those, there were enough accuracy and accuracy challenges for it to be reliable, where you can actually trust it. You can use it in changing your everyday workflows. Where we see deep learning is really trying to change that landscape. It's really bringing new capability and new capacity, but the fact that deep learning networks and architectures are very scalable, they mimic human behavior, they can actually help solve, difficult real world, understand video in difficult real world situations like rain or fog or snow, and do it pretty well. Now, a lot of times we get asked this question, so where is this intelligence going to reside? Where is all of this smartness going to reside? It's a relief, and the way we think, there is no one good answer or no one good place where all intelligence needs to be. We believe that intelligence is going to be spread across the entire spectrum of deployments. And it will be really dependent on the problems that you're trying to solve. So for example, a parking entrance, or access control systems, either using ALPR or using face recognition. Everything doesn't need to be sitting in the cloud. It could be right at that edge deployment where your cameras are. Thinking about airport security or campus level security, the intelligence could be on the premises. Thinking about city level problems, thinking about delivering, or helping with traffic engineering, for example. Those could be perhaps sitting in the cloud because they are bringing feeds from thousands and thousands of different cameras. So it is really, the way we think about this is, it's really a function of the problem you're trying to solve that will define where the intelligence can sit.
Does that play any role in the traffic management aspect of AI?
Like in
Just like it, as in, today Waze keeps track of how fast traffic is going, where we are physically in our car, how fast traffic is going 3 miles ahead of us and 2 miles behind us. Does that keep track of that?
Absolutely, absolutely. You can almost treat that as an additional sensor in addition to video, right? But I'll give you examples where we see real world deployments now. So for traffic specifically, these systems are being used to monitor camera feeds from traffic intersections. So you get a good sense of the city planners, the city operations center gets a good sense of the queue lengths, the direction of traffic. So what used to be pre-programmed intervals for how long it's going to stay green or how long it's going to stay red is now completely dynamic and real time.
Does that hold true when I'm an I-80 in the middle of Kansas?
Perhaps not yet. Not yet. Can it be? Probably, right? But it's starting to become real on at least your surface roads on traffic intersections. Another great example of this is energy management, where we all know that we're going big time towards LED lighting for our streets, and changing the intensity is very quick compared to the old the light lamps. So if there is no traffic on the street at all, the lights are dimmed to 50%, for example. But you actually see a car turning left, you preemptively fire up all the lights to their maximum intensity. So these kind of smarter ways to manage energy and to manage flow is what we have started to see. Using video as your primary sensor.
What you're saying you're starting to see, are you seeing them on paper as one day we'll do this? Or you've seen someone's doing this, you come around the block and the lights turn on?
Actually, interestingly, real world deployments.
Really?
Real world deployments. I would say these are all in some level of a POC stage,
Sure.
But real world deployments in Europe, in Asia, absolutely. So with this idea in mind, where we think that AI and computational horsepower and smarts have to be spread throughout the entire fabric, all the way from cameras to your data centers, we announced a platform earlier this year called Metropolis. It is really our way of bringing all the components that we have inside NVIDIA and connecting them through rich software layers. So you can build scalable systems. You can build different devices. You can build different form factors. So now smarts can live perhaps in a camera all the way into a smart NVR or a DVR to a bigger appliance to a bigger server. And all of this is supported by infrastructure to create deep learning-based solutions. And today, our focus is continuing to be on video, but as we look at a year or 2 years from now, I can see us bringing other types of sensors into the mix. For example, lidars for nighttime operation, for presence detection as an example. Other type of proximity or occupancy sensors to help with, for example, occupancy analysis in buildings or your HVAC control, all seamlessly tied into one platform.
Just one question. When you're talking about the Cam VR server and devices, so you're suggesting that the Jetstone board will be incorporated into them in order to enable that capability?
Yes, we are seeing definitely Jetson. So Jetson is one of our smallest form factor boards out there. It's actually the size of a credit card, roughly 55 millimeters by 87 millimeters. It's a single board supercomputer with memory and storage and Wi-Fi with the SoC. It's the same GPU capabilities that you would find in the bigger presence. What limits is thermals and the size in terms of how much horsepower it can deliver. But the littlest of these guys is like roughly a teraflops of compute. Give you a perspective, that's roughly equivalent to an i7.
Do you have,
This is completely replace your desktop computer.
oh no, absolutely. No, do you have that in a different form? So instead of the credit card layout in like a bridge, a piggyback layout?
For that, today we have smaller cousins of the big Tesla card that you see. We have smaller cards that are half height, can fit into like a mini ITX or a small desktop workstation type form factor. So this slide does not represent all the different product SKUs or sizes or I would say form factors that are out there. But fundamentally, if you look, you can generally divide them into three big buckets. One is the Jetson class of devices, which are like literally credit card size, single board computer. You plug it in, it boots up Linux. That's what a lot of OEMs have started using into super smart cameras or NVR and DVR type applications where you're dealing with perhaps one channel of analytics in a camera to 4 to 6 channels in an NVR or DVR. So that's one bucket. The other bucket is literally add-in cards that are like PCI Express. You've seen them as video cards in the past, right? We still continue to have those, but we're taking a notch up where these cards are, the Tesla family, where these are purely compute accelerators. They're just delivering. They can do a lot of traditional video encode and decode and composition of images and whatnot, but they are delivering hyper performance for AI and computer vision type workloads, all the way into the third class, which is the full-blown servers. Does that answer your question?
Yeah, but I'm also debating why would the manufacturer, let's say, try to adopt the NVIDIA card into a camera instead of just pulling the string from the camera and doing the smart AI on the server?
That's a great question, and to be very honest with you, I don't think our intention is to have NVIDIA technology power every single camera in the world. In fact, I can tell you that from our vantage point, we believe that less than 5% of cameras will require this much of intelligence and capability. I mean, there's a serious horsepower, there's a serious computational capability. So you're absolutely right. What we believe is Jetson class of devices will perhaps be better suited for NVRs and DVR type application, where there is a decent amount of transport capability, there is a decent amount of compute capability, and you are aggregating a small number of channels. But there are applications where we see remote camera deployments, for example, in case of critical infrastructure security, monitoring train tracks, deployments in border locations, where there are normally powered by renewable energy, solar panels, or little wind turbines. Sending out video back is very, very expensive because pretty much the only connection you have is an LTE connection. So that's where you pretty much run all your analytics at the edge and just push out the scene understanding metadata back to a control center.
That's been done today.
Was that?
That's been done today.
Yes, exactly, exactly.
Solutions. I mean,
Exactly.
They are doing on the edge and getting feature extraction and that's
Yep.
out to a main server. So
Yep.
I don't need AI for that. Now, what I'm trying to understand is what is the added value that will want me to use that on the edge. So what is the type of implementation that requires me to use that and not the traditional video analytics that provides me that features on the edge?
When you say edge, I mean, like I said, edge to us could be in a camera. Edge to us could be arguably an NVR or DVR. Edge to us could be an appliance.
I'm talking about critical infrastructure outside, let's say, cell tower.
Mm-hmm.
Okay? You want to just check the perimeter to protect it, so using cameras.
Mm-hmm.
So why would I use AI for that and not use traditional?
I think it's all about accuracy. It's all about accuracy and scalability. It's making sure that it works in rain, snow, and fog. And that is those corner cases where we traditionally had problems with traditional analytics is where we are seeing deep learning helping. And so using this platform, we are, on a daily basis, we're seeing more and more new capability and efficiency being delivered by, industry leaders. I mean, Abdulon's search by example, for example, that you guys must have seen everywhere. That's all powered by AI and deep learning capabilities. Video synopsis, summarizing your video and what happened and when it happened, and compressing it to interesting events is a capability that's being powered by deep learning engines. I was mentioning performance during weather impairments is definitely being helped by deep learning. Fundamental speed improvements, understanding the scene to deliver better situational awareness. And this is both for safety and, in many cases, retail applications. So, for example, double-clicking into a person, its attribute and understanding gender, understanding their clothing, understanding color of the vehicles, the type and the make and the model of the vehicles. A lot of this capability is being delivered through the power of AI and deep learning. We have almost 50 plus companies we see that we are working very closely using the power of GPUs, the power of AI and deep learning to deliver their solutions. FST at face recognition, that's one of the interesting applications.
I work for Briefcam and Engine VI as well, so.
Oh, beautiful. And solutions are available in all kinds of form factors and functional capabilities. Everything from single channel servers to servers that span through thousands and thousands of channels for video understanding are being developed and being deployed in real world by these companies. Up until a few years ago, when we first started, working in the public safety and security industry, we got a sense that there was this perception that graphics and video cards and graphics processors, GPUs, they were exotic. They're exotic things. But guys, they are not. They truly are not. They are available from practically every single OEM and vendor that you today deal with in various forms and functions. I mean, there is a laptop, there is a small PC, there is a workstation, there are big servers. We ship millions of these things year over year. They are available as cloud components from the likes of Amazon and Microsoft and IBM. So if OEMs have cloud services that rely on AI and deep learning capabilities, they can harness the GPUs in the cloud. They don't necessarily have to bring physical devices into and deploy them on premises. But fundamentally, if there is a need for video analytics, we see that GPUs will become indispensable. GPUs will become indispensable because of three fundamental things. One is most of the deep learning work that is being currently done, whether it's in research, whether it's in production, and whether it's massive city-scale deployments, that's all being done on GPUs. All that innovation is happening on GPUs. So there are fundamental architectural. It's almost like that architectural hook that GPUs have provided that's going to stay there for as far as we can see to the future. And there are technical reasons why it happened. For one, GPUs are these big parallel processors. So for video type of workloads, for example, they provide a massive amounts of throughput compared to your traditional CPUs, and orders of magnitude higher. For deep learning type applications, it could be as high as 30x compared to a dual Xeon CPU cluster, right? 30x. And it's not like you're taking thousands of watts for that. No, it's 150 watt, 175 watt type of a solution. So suddenly you're transforming your Xeon processor server into a super server, into literally a teraflop supercomputer by adding a GPU inside it. And that does a couple of things. One is, you obviously get more throughput, which translates into one of the two things for you guys. One, it gives you more channel density, so you can push through more camera feeds through the same hardware and process it. Or two, for things like forensic investigations, it rips through the data much faster. Much faster, an order of magnitude faster. And what's unsaid here is, because now you're not really increasing the amount of hardware or the number of physical boxes you're deploying, your total cost of ownership from an end deployment perspective, your electricity cost, I mean, these systems potentially run for 24/7, 365 days, 5 years in a row. So the total cost of ownership, the total cost of operations is going to be significantly lower compared to if you were just adding on bigger and bigger CPU clusters.
Question. So in that scenario, so 5 years gone by, your GPU is at the end of its life cycle, you need to replace it for whatever reason. Is it not going to have to start that whole training process over again to develop all of the learning that it's received over that time?
No, absolutely not. So the way to think about this is, GPUs are the physical hardware, right? So it's very much like CPUs, right? It's not meant to replace CPUs. It's really augmenting the capability of your existing computers. So it's the physical hardware, and then all the power of deep learning is into software, into the software you write. So sure, just like you've been upgrading your CPUs over time, and your existing software works plus minus something because of your upgradability challenges, right, or backward compatibility challenges. Same setup with GPUs. You bring in a new GPU, you may not consume as much of it as you were in the past, but technically the same software works. And a lot of these GPUs, especially the Tesla family that I mentioned, I mean, these are enterprise class. They are sold for like 5 and 10 years at a time, so that's their life cycle. And they are, I mean, they are tested and you know, developed for data center operations. So they're supposed to run at full max speed, max clocks, 24/7, non-stop, right? They're built, they're purpose built for these type of applications.
So is it essentially modifying its own code, and it's using the hardware as the processor, but it's still residing in the memory of the computer?
You can say, so the way it would work is, you literally have like software programs. Think of it as software program. So deep learning is a software program. It resides into the memory of the computer. It sits on the disk when you turn on the computer, so it's all stored on a hard drive. You boot up your computer, it gets loaded into the memory. And then, like you are running your Microsoft Word or Microsoft Excel as applications, think of it as a deep learning application. The difference is, it would use or harness the power of the GPU as a big parallel computer. You can run deep learning on a CPU, but the fundamental difference would be CPUs are designed for sequential processing. They do some things really good, like if-then-else statements, like looping. But as when it comes to parallel processing, which is how our brains are wired, just like how these deep neural networks are built, they require tons of parallel computations. And so GPUs, like some of the smallest GPUs are like, 256 cores. Some of the bigger ones are 6,000 cores. 6,000 cores. That's a lot of parallel computation that can happen. And that is what gives them the power.
So is the annotation data held on the GPU in most cases through the decision processing?
No, you don't need the annotation data for runtime. Annotation data is only needed one time during your creation of the network. So if I step back, so there are two steps. One is building your network, and second is deploying your network. So building your network is essentially a one-time lab exercise, potentially, right? Where you take a ton of annotated data, you give it to the network and say, these are all guns, these are all faces, these are all cars. The network learned it. Now you forget the annotation data, you take the network and then put it into your deployment systems. So the annotation data is sitting in your labs, in your factories, in your offices. And now your your unstructured data from your real world video cameras is coming through this network. It's almost like this black box, where it reads it on a frame by frame basis, and output is, this was a car, this is a blue truck, this is a two-wheeler, this is a guy with a helmet, right? That metadata stream continues to flow out.
That decision is made where?
In your deployment systems. So what you would deploy on premises, or what you would do in your NVRs or DVRs. And that information potentially can be sent back to your back office for building better networks over time.
I suppose where I'm extremely confused, and I apologize, is the bigger picture overall environment. If I buy a magic box from one of those companies and it has a neural network, or it has a deep learning network in this magic box, and they don't connect it to the internet,
Yeah.
it'll do its thing. But
Yeah.
is there an infrastructure being put in place so it gets like, my antivirus gets a daily update of new information, new learnings? Are these networks going to get daily updates of another system learned what a cat looks like?
Yes.
Or are we sharing data amongst them?
So it depends on OEMs to OEMs and how they're building their systems. I don't think there's an industry standard to do this. But each OEM, the likes of, for example, Avigilon or Hikvision, they would have the infrastructure to constantly update their backend or their deployment systems. So they would be constantly putting or pushing out updates on a weekly basis, monthly basis, 6 monthly basis, whatever, with newer models saying this is a better one. This is version 2.0, which is better than 1.0. It can do with, it can do 6 more types of different objects. or it can do the same objects with 25% more accuracy. So they can definitely put this closed loop infrastructure where just like your antivirus updates, they can push network updates.
It seems, I don't know, again, I apologize if I'm not getting it. When you go on Google or Microsoft Azure or any of those sites online, right now you can go to Google and they have an API where you can do deep learning. And their machine is learning from every user across everywhere, every day.
Yes.
So it's not that they're pushing out updates. It's today I looked and showed them one cat. Now everyone knows what that cat is.
Right.
Where several of these brands, if I'm understanding correctly, are building their own little thing that's just learning what your cat is doing.
Yes.
I'm not saying which is right or wrong, because I'm sure some clients won't want their video pushed to the cloud. I get that. But is there any alliance or any strategy around this industry-wide, or is everybody trying to figure out their own way to do it?
That's a great question. No, unfortunately, right now everybody's trying to do their own thing. And in case of Microsoft, for example, right, with their partnering with APIs, a lot of that power is delivered through GPUs in the backend, for example. So the way we see it is, so between us and the end customer, we see the OEMs and yourselves as sort of that bridge. And each OEM has taken a slightly different approach depending on the kind of challenges or products that they are trying to build. So for example, sending video to cloud and running a lot of this in real time has cost and network bandwidth implications. And as the resolution goes up, as the frames per second go up, that cost goes up. And compute may not be a problem in the cloud, but data ingestion is a massive, massive problem. So in those type of setups, perhaps doing it on premise makes more sense. So I think what you will find is there are n number of and please teach us or please let us know if we think we're missing something or we're not seeing this right. But last couple of years since we've started working this in this industry very, very closely, this was one of the fundamental learnings we had was I cannot just rely on cloud for everything, or I cannot just rely on for edge for everything. Every situation or every deployment will have its own sort of challenges, which will force us into deploying it one way or the other. And so, Microsoft services and Microsoft Cognitive Services, they're great in their own way, and they solve a certain set of problems. But for example, if you're trying to build a heat map, you're not going to get a native heat map out of that. You need a higher level application to consume that metadata and build a heat map. So many of the OEMs have that almost as a built-in application, heat mapping. Or people counting, occupancy analysis. So this is being deployed in transit buses or trains for occupancy analysis. And that is not happening in cloud. That is happening somewhere very close or in their operations center. Because it's very expensive for them to pump data all the way back into the cloud and do it. Does that partly answers your question?
Yeah. The answer of no one's figured it all out yet. There's 100 different options. The scary part. I was hoping there was a best practice or an industry standard. It sounds like we're not there yet.
In fact, I was in the previous talk here around OnBIF, and I found some of that very interesting and intriguing. So I'll kind of lay it out in the open. One of the fundamental problems with standardization here is suddenly, this AI and deep learning networks are providing you a lot more metadata than was available before. Like you can literally double click into every object and say, sure, make and model are there, but dents and scratches and colors and bruises and beards and glasses and everything is double clickable suddenly. And none of these solutions share a common language to pass this either to a VMS, pass this to a higher level application layer. And which is actually a significant challenge as we see it that we have all these different applications that speak their own unique language, their own metadata encapsulation. And then every VMS or every application or every UI that the end user will see will have to customize based on the end application or the engine that's underneath it. So, I mean, frankly, the way we see it is there almost needs to be a standard of managing all this rich metadata. And then once you have a metadata communication standard that can delve or that can share so much information about your scene, perhaps some follow-on standards of how these networks and these things are maintained over time. Until that, they all talk different languages. Everybody talks a different language. Avigilon has a different language. Milestone has a different language. Hikvision has a different language. Microsoft has a different language. And with that specific thing in mind, and the fact that we see that the nature of these deep learning systems is, I mean, in all honesty, these are like roughly 5-6 years old. They're starting to just scratch the surface. And we're seeing that a lot of innovation is coming from startups and smaller companies out there who are very agile and very eager to do something fundamentally different. Plus the fact that they don't all speak the same language. So a few months back, we put together this formal program where we are trying to bring a lot of these application developers, call it deep learning apps, whether it's a face recognition app, whether it's an ALPR app, whether it's an anomaly detection app, whether it is a heat mapping app, you name it. We're trying to essentially bring them and give them a platform so they can take their word out, their message out, and hopefully over time we can work with all of them to come up with a common language that helps communicate all this information coming from different sources into a common fabric.
But isn't that what an API software development kit is used for, is where you have your deep learning system that's doing the heavy load of, the heavy work of the processing, and then giving the API software development hooks to the manufacturers of the VMS platforms? I mean, why do you need a common language necessarily when VMS platforms will utilize their own quote-unquote partners, whether it's IBM or somebody else, PlateSmart or whoever, and utilize those APIs and those hooks to be able to write the inputs for what they're going to use for their outputs?
The short answer is yes. In principle, what you're saying is exactly what needs to happen, right? The challenge is, there are hundreds of different app providers now that are starting to use and build these deep learning applications for unique things. To tie it into a bigger scene understanding solution, a lot of this information has to flow to a higher level, perhaps a VMS. Each of these apps have a different way of encapsulating data. So either it's up to the VMS providers to take on the heavy workload of figuring out the interface layer with each one of these guys, or we come up with some kind of an MPEG-like standard or some standard to encapsulate this information so that it becomes VMSs, or it allows VMSs to scale. Right now, if Milestone can talk to 27 companies, that's all they can support, for example, right? What about the 28th and the 29th company? What about the company that starts to do undercarriage bomb detection? I actually have a company that has started doing it, and they do it with extremely high accuracy. So now their metadata types are slightly different. So how to communicate this information to a higher level to make it usable? And so, frankly, we all have to come together, and we all have to work together. It's not his work or my work or their work. We all have to work together. We as the hardware and the software SDK providers, VMS as the interface between what a user sees and the lower level applications and the middlewares at the core IP blobs that provide this metadata to all hopefully tie it into bigger end applications. That is, I think, that will hopefully drive these solutions or to the next level. They will make it scalable, easy, literally turnkey.
Well, I think today most of the companies are trying to accelerate the results basically using the GPU to get more output.
Yes.
That's one of the core fundamental issues when dealing with video analysis. What you are referring to, I think, would be the next step of how to all of them collaborate together.
Yes.
Now, take into account that today, I think maybe 1% of all the video is being viewed or reviewed.
Yeah.
That's another problem. I mean, for all of you who are deploying cameras or systems, everything is being recorded. No one can see all the videos. No one even is capable of reviewing all that video and make conclusions about how to make better the security because they don't have time to do that.
Mm-hmm.
Now, I can definitely see that if that could bring a lot of conclusions out of reviewing all of the video, that would be a good result. But
Yeah.
Well, in our industry, it took 3 or 4 top-level manufacturers to get together and say, we are going to create this standard and see if it sticks. There was actually 2 standards for video connections in the beginning, and one went, the industry went basically kind of one way, and utilizing that is NVIDIA going to partner with some of the other big ones to try to create this?
Mm-hmm.
I mean, you're already in that process?
We're starting to work on it, I would say. I think it will take a lot more work to bring this all together. But yes, we are starting to work with the leading VMS providers as a starting point and started thinking about it or started drafting, some ideas, I would say. But we are nowhere close. We are nowhere close. I think we have a lot of work ahead of us to make it a reality.
Are there any library repositories, maybe at universities, if they're not going to be in corporations, and if you're not going to hold them, or a company can shortcut into having some learning of, let's say I'm looking for individuals with weapons, as an example, where you can go and pull this information down and utilize it, or is it all privately held?
Generally, what you would find is a lot of like in your case, weapon detection as an example, right? So there is a whole research community around it, but now we're starting to see commercial solutions that you can actually license as an application. And so what we are starting to do is, with this partner program, essentially we're trying to build a catalog of all the solutions out there that are commercially deployable today. Not science projects, not research, something that you can, license today. And where we really want to get to is, download now.
Absolutely.
Try it for 30 days and see how it works. And if you like it, call the manufacturer, call the software provider, and license it commercially. That's our goal for next year. We are not there yet, but to begin with, we have started assembling a catalog. These are a handful of names that we have publicly announced, so I'm putting these here, but there are about 15 other partners that are in the background that we are constantly working, and next time I present these slides, probably there will be an additional 15 names for software vendors, software providers, doing exactly things like what you mentioned. So just to recap, we're closing to the end of the hour. Just to recap, I think the fundamental message that we want to bring today is, video, you guys are all dealing with tons and tons of video. I think there's a lot of opportunity out there that is untapped by actually harnessing the information that's contained in that video. And now we actually have a tool. What we believe is we are on the right trajectory for the first time to be able to go and harness that information in a meaningful way. And it's less exotic, it's far less exotic, it's actually far more real than what you think it is. So we would love to understand what are some of the near-term problems that you would like to see solved, especially around video, and then try to see if we can map this core technology, perhaps by matchmaking with OEMs or software providers, or fundamentally doing something on our side to help solve those problems. That is the big message that we really want to bring to the table today.
When you look at the smart and safe city movement and these public-private partnership initiatives, and a lot of this is driven by public safety, and also the inner city business districts. From the standpoint of where you are as a solutions provider, what is your responsibility and what is your initiative to dealing with the public and private sector, not the vendors, to try to get some of these solutions, if not initiated, just on the table so they understand it, because none of this is going to be driven, purchased, or implemented unless the people that are, charged with the smart and safe city initiatives understand what the hell's going on.
Yes, definitely. Education is a big component of it, a massive component of it, I would say. And we are definitely ramping our efforts, working with cities and research organizations that work with cities, could be leading universities in many cases for smart and safe city projects, for example, to constantly educate them on what the possibilities are. And by no means I'm saying it's all said and done and this is the answer for all things. No, it is not. We're like I said, we're starting to scratch the surface. We are just unboxing the capabilities, and but everything that we have seen in the last few years, we believe that we are on the right track. Everything that you see getting impacted in your daily lives, whether it's search, whether it's typing on your Facebook photos, whether it's Hey Siri and Google Now, and the fact that they're working reasonably reliably well, day in and day out, it's the same kind of technology that's powering all of that. So that's what makes us think that we are on the right track for solving some of these video problems that we face. So absolutely, I think we're ramping up our efforts in educating, ramping up collaborations with universities and research organizations that help drive that awareness and decision-making into those.
And also, the private sector, like in Minneapolis, Target Corporation is extremely involved with the Smart City Initiative up there, trying to drive that. Home Depot in Atlanta. You've got the corporate sector getting involved now. But again, like you said, it's got to be an education process.
Absolutely. Yes, please.
How far are we, just using that picture, I know nobody can see the future, but using that picture, how far are we from, if that car hits those people, automatically calling the police and sending a police report? If that car rolls through the stop sign, automatically sending them the ticket? How far are we from those things? And have you seen any regulation?
It's real. It's absolutely real.
Well, it's real in a test environment, or is it real in it's going out to the market?
It's actually going out to the market.
And have you seen any regulations around Big Brother and every time I go 51 miles per hour on the 50, I'm getting a ticket now? What are you seeing there?
I would say we're seeing...
I speed for the record.
They'll call it a service fine when you register your car.
We're seeing more subtle use cases. We're seeing, for example, bus lane violation. So a lot of the big cities have these transit authorities and dedicated bus lanes. And, public transportation is critical in backing up a lot of cars, and jamming traffic is a big problem in those cities. So they have started deploying cameras and these systems in I would say, near real time. They process the ALPR of the violator and push out the ticket at night. And so indirectly the systems pay for themselves, right? I was mentioning traffic light example. I mean, we have deployments in Spain, we have deployments in France that are controlling street lights based on this. So all of this is real. It's just not everywhere today. It's just not, in every city today. And it's very unfortunate for a variety of reasons that we in US are a little bit behind with how things are, compared to how things are running in Europe, for example. And Europe started from a resource optimization first, more than anything else. Actually, the beauty about this is you don't even have to send a video. You're just sending the queue length and the speed and the number of cars to control the traffic light. So from your privacy concern perspective, I mean, Europe is actually some of the strongest rules on privacy. But we still see a lot of these systems being deployed more regularly often there than now in US we've just started talking about, so most of the cities have started putting these smart city corridors. And the G's of the world and the Phillipses of the world are starting to help build infrastructure around it. So we've started engaging on those fronts to see how some of these problems can be solved here as well. Yes, sir.
Where are you with incorporating augmented reality? With incorporating the augmented reality layer on the
Augmented reality layer?
Yeah.
It will happen. It will happen. It's not difficult. In fact, at IFC West, I saw a couple of demos with VR headsets and your control, like your operations center almost on a VR headset, where you can dynamically switch screens and do some really exotic stuff. The beauty about it is it's the same GPU. You can use it for multiple things. You put one GPU in. Sometimes you run it for analytics. Sometimes you run it for displays. Sometimes you run it for rendering purposes for AR and VR. That's actually the beauty about a lot of this technology is it's not fixed function. It's actually as programmable as you've ever known it to be. It's just one additional application which happens to be big and impactful that is being added to GPUs. I think we're out of time. That's what I've been signaled. So if there are any questions, I'm happy to take it outside. But thank you very much. And